Hi, everyone. Welcome and thanks for joining us today for our webinar on industrial IoT and intelligent edge connectivity. My name is Scott Siphon with Moxa, and I'll be your moderator. Before we start, I'd like to introduce our presenters. From Moxa, we have Robert Jackson, who has over 15 years of industrial automation experience and is currently responsible for Moxa's Global IIoT Partner Program. Presenting alongside Robert will be Kevin McCluskey from Inductive Automation. Kevin brings several years of expertise in the field of industrial automation, software integration. All right, with that said, I think we're ready to get started. Just a side note, if you have any questions during the webinar, please submit them in the questions pane, and Robert, Kevin, or myself will try to address them throughout the webinar or during our live Q&A at the end of the presentation. Okay, that's it for me. Let me hand it over to Robert to get us started.
Thank you, Scott. Welcome, everyone, and thank you for attending our webinar today. To help frame our discussion, we are all experiencing a new technology. This technology is the transition from centralized servers and PCs to distributed cloud-based platforms and handheld devices. As is common with major technology trends, we're at the early phases of the Industrial Internet of Things, or IIoT. One of the ways to monitor these transitions is provided by Gartner's Hype Cycle. This shows how disruptive technology from the technology trigger goes through a peak of expectations, then a trough of disillusionment, and moves toward true productivity gains. This occurs with both technologies like IoT, as well as within individual markets or applications. For example, customers who are enabling remote monitoring of a large number of remote assets that are also using cloud technology might be a little bit further along this path than a refinery customer evaluating options for a transition of their DCS. With the understanding that each of you attending today might be at a different place in your evaluation and adoption of IIoT technology, we wanted to start with some industry trends. Investments in the cloud have been occurring for a few years. In 2015, Amazon was a first mover and announced AWS IoT as revenue success followed, enabling significant growth in AWS revenues. Microsoft and Google also quickly engaged. Recently, in fact, just recently in the last 2 weeks, we have seen major announcements from Microsoft, including a corporate reorganization where they have formed two groups, one focused on experiences and devices, and the other focused on cloud and AI. Without mentioning Windows, this seems to signify a true transition to cloud and AI for Microsoft. To support that analysis, just last week, Microsoft announced plans to invest $5 billion over the next 4 years in IoT. So we should ask ourselves why. The short answer is that cloud was the first technology trigger and is already driving significant financial and business changes. Just how significant? We'll take a look at some of these business trends. The top 3 cloud technology providers are approaching or surpassing $18 billion per year in revenue from the cloud. Growth rates, even with this large number, remain in the 30 to 50% range. And Microsoft, in the third graph, is specifically on track to easily surpass $20 billion in 2018, which they predicted a few years ago. Many others are also on this path towards $20 billion and beyond. And with these types of growth rates, we expect to see this trend towards the cloud continue. So from a technology perspective, what is driving this business revenue? Well, in short, software platforms is the simplest takeaway, but let's dig a little bit deeper. Building on the trend of software enablement, the Internet of Things is really about the technology behind these new software platforms. One that I think we can all relate to is the move from Excel and Word, from local application installed on your PC, to cloud-enabled applications where all of that data is hosted and accessible through a web interface, and you can access that application from any of your devices, whether it be a PC, smartphone, or tablet. For the Internet of Things, the ARC Advisor Group has identified 4 new software platforms that are driving disruption, much like cloud-based Word and Excel files. The first and base platform is device connectivity. The second layer builds on top of the connectivity with distributed computing or the compute platform. Then cloud platforms enable a wide range of software applications. And finally, new platforms are becoming available for analytics. We'll walk through 3 of these in the next slides. First, device connectivity platforms like Moxa's IoT Edge Gateway are enabling connectivity to real-world data, and also options for device management, device connectivity. And this connectivity, I must note, can be both upstream, like cellular, Wi-Fi, or Ethernet, and downstream with industrial protocols like Modbus. In addition, there's the ability for new app development. These IoT level platforms also enable public and private cloud connectivity with APIs. A little bit more on the APIs will be coming in a few slides. The next two levels can best be summarized with infrastructure as a service. Here, the major technology leaders are all making investments and seeing significant growth in the physical computing and storage infrastructure. And even more importantly, the software platforms to enable all types of application and software as services on top of them. Products like Microsoft Azure are hosting Office 365 data, as well as industrial data. Microsoft's also creating physically separate clouds in major countries around the world, and in certain applications enabling private companies to host their own instances of these clouds. In the industrial space, Microsoft has an extensive roadmap for edge connectivity. And here at Moxa, we are working closely with them to provide the integration that you guys need as our customers. Amazon was also one of the first to invest with AWS and AWS IoT, and Moxa is closely working with them as well as they expand further and further into the industrial space, for example, with capabilities such as Greengrass. The final software platform trend we are seeing revolves around the analytics, including data analytics, machine learning, and even artificial intelligence. Today, much of this technology is targeted at the consumer space. However, as the industrial IoT space matures, we are seeing targeted analytic capabilities for industrial applications like machine vision or autonomous vehicles. With that, I'd like to get our first poll question of 3 from the audience today. So we're going to go ahead and load the poll question, and the question is, what cloud infrastructures are you considering? Option A is Microsoft Azure, B is AWS from Amazon, C, Google Cloud Platform, D, IBM, and E, not currently considering any cloud infrastructure. Please select on your screen one of these options. If what you're considering is not listed, pick something that's close, something that is similar to what you're evaluating today. And then I also understand some of you might not currently be considering specific cloud infrastructures, so please select that last option, just to give us a scale of what you're working with and what interest you have around the cloud architectures today. We'll give you guys just a few more minutes, and then we're going to go ahead and load the results and see what the audience response was. Okay, Scott's leading our poll. Scott, could you go ahead and enable those results so we see what the audience is considering for cloud? Interesting. As expected, AWS is doing quite well. We see a lot of success there, but a close second is Microsoft Azure. But as I expected, almost half, 42% of you, are currently not yet considering cloud infrastructure options, which is great because there's a lot of technology that we need to also make sure is familiar and available and ready in the market as we move towards the cloud. So with that in mind, that many of you are evaluating perhaps the broader technology and not specific cloud architectures, let's talk about some of the modern IoT architectures that we're seeing. These broader industry trends that I've been discussing are having an impact on real-world IoT applications, and our team at Moxa is starting to see some similar architectures emerge from these applications. The first is connectivity from IoT edge gateways. These connect directly to devices and sensors and then to cloud architectures. These clouds can be public or private. We're seeing several industries adopt this architecture, and admittedly, it is similar to the traditional M2M or remote monitoring applications. However, with this approach, customers are adding IoT edge gateways to existing infrastructure and relying on cloud infrastructure to provide device management, storage, and dashboards for visualization. And I think that last piece is pretty important. It's all about the device management story and centralization of visualization that really is where the cloud begins to differentiate itself. Many also are starting or plan to in the future utilize the data analytics and some of the machine learning capabilities that these platforms offer. but admittedly, we're still early in that machine and analytics phase. The second architecture we see is a new trend of hosting SCADA solutions in the cloud, often using a software as a service business model. These edge to modern SCADA solutions speak today's RESTful web APIs and often use the same MQTT or AMQP protocols we are seeing in edge to cloud. Here, we at Moxa are working with industry leaders like Inductive Automation to make sure that you have edge gateways and connectivity solutions that enable existing devices and sensors to participate in these new IIoT applications. The third common architecture we are seeing is edge to traditional SCADA. You will notice in this architecture I've had to move SCADA down a little. This is actually a critical component. For these architectures, one key piece are the APIs. With these traditional SCADA systems, we need to convert their polling protocols to new web APIs or RESTful web APIs. An even better approach might be publish-subscribe protocols like MQTT with statefulness. In just a few minutes, you'll see a demo from Kevin at Inductive Automation that highlights the value of publish-subscribe and statefulness. In this third architecture, we're seeing large industrial providers, including GE, Schneider, and Siemens, along with others, who are offering their own cloud software solutions. Many of these are hosted on AWS or Azure, but those details are often abstracted from the users. In other cases, we're seeing some of these customers connect directly to Azure or AWS. So in these architectures, I mentioned the difference between polling and publish and subscribe APIs. For the IIoT, this is such an important foundational technology topic that I wanted to create a few slides to graphically highlight the difference. If you consider the current architecture for many control systems, you have a PLC that reads data from a set of registers. Once you go beyond one PLC, they are connected via a bus, and these protocols all work with a set loop rate or poll rate. And the master device communicates to each device in loop, let's say once every second, and reads the registers on that device and then moves it to the next PLC or RTU. This is a well-known and proven architecture, and thanks to advances with Ethernet speeds, the amount of I/O and polling rates continue to increase here. However, the way modern IT systems, like the web work, uses a different architecture. This is publish-subscribe. In this architecture, any number of devices or subscribers can connect to a server or publisher, and data changes are communicated simply by having the publisher update the data. This architecture allows for much broader scalability as the subscribers expand without impacting the configuration or purpose of the publisher. You can also scale the number of servers or publishers and have different subscribers connect to different sets of servers. Now, needless to say, both of these architectures are widely used and well proven. They are also both well suited for certain applications. For example, high-speed closed-loop motion control is ideal for a polling style architecture, while distributed remote asset monitoring is probably better suited for the publish-subscribe architecture. So if both of these architectures exist and will continue to serve their respective applications well, can you have coexistence between them? The short answer is yes. A new product category of IIoT edge gateways has emerged, and these products provide that bridge from polling to publish-subscribe architectures and the APIs we're now using in the IIoT. Moxa has a full product offering here with Linux or x86-based computers and software that enables device management, connectivity, and protocol conversion, both from industrial protocols and to publish-subscribe APIs like MQTT, AMQP, and native cloud communication and configuration options. Moxa's edge gateways are open platforms that support both Windows and Linux. In addition to the benefits both of these operating systems offer, Moxa also offers 10 years of Linux OS support. This ensures any changes to the base OS are initiated by the customer, and it also offers options for the customer to deploy bug fixes and security updates at their own discretion. In addition to an open platform, remote connectivity is critical for many of these applications. A key technology is reliable 4G LTE, and Moxa offers this with industrial hardened designs and minus 40 to 70 operating temperatures. It's now time for our second poll, and here I'd like to dig a little bit deeper into the industrial protocols that you're using today. So, are you using traditional industrial protocols such as Modbus, Profibus, or DeviceNet? New Ethernet-based protocols such as Ethernet IP, Profinet, or EtherCAT? Publish subscribe protocols such as MQTT, AMQP, and OPCUA, or others? Please select the one that you're most commonly using and is newer for you, because I'm sure all of us have used the traditional industrial protocols. But if you today are starting to really rely on MQTT or AMQP, we'd like to hear that feedback, that this is the latest generation of protocols that you're starting to adopt. Again, please make sure you click on your screen in order to provide that feedback. It's great for us to see the results from a broad audience like this. We'll give everyone just a few more minutes, or excuse me, seconds, and I'll go ahead now and ask Scott to update the results of our second polling question. Interesting, kind of what you would expect to see. Ethernet-based protocols are the majority with 62%, but we have some new emergence of publish and subscribe with MQTT and AMQP. I want to highlight again, here at Moxa, we're about interoperability between all of these different types of protocols. And so I'm sure you're familiar with our capabilities for traditional industrial protocols like Modbus, the way that we support you with new Ethernet-based protocols, and how we want to work with you as new technology emerges with this IoT for publish and subscribe protocols. Most interested to me is that this covered almost 97% of the protocols in use today. So it doesn't seem like a lot of people are using other, which is good. So finally, to enable the device platform, Moxa offers our ThingsPro software. This enables device management, remote configuration, and connectivity to industrial protocols. ThingsPro includes a server that can be hosted on Azure or AWS and provides a geographic view, the ability to group devices and implement remote updates, and shows individual device status, as well as provides the capabilities for device management. Each edge gateway with our ThingsPro gateway installed offers a local web interface for device configuration and setup as well. Here you can see key device information like hostname and software version. You can manage network settings, including cellular and other radio configurations. You can connect to industrial protocols like Modbus and set up and configure cloud infrastructure connectivity, like connectivity you see here to Microsoft Azure. Finally, you can also configure and provide connectivity to modern SCADA solutions like Ignition through Ignition Edge. In addition, these features are all exposed through a web API. So for customers who are using their own device management software, they can access all these same device management features through Moxa's API, allow them to have hardware from different vendors, and use the same device management solution across their network. I would like to now introduce Kevin McCluskey from Inductive Automation to provide an overview and demo of a modern SCADA software approach. Kevin, thank you for joining our webinar today. Please share more about this new modern SCADA architecture.
Thanks, Robert. So as Robert mentioned, my name is Kevin McCluskey. I am co-director of sales engineering at Inductive Automation. And I thought before jumping right in and showing you the demo, that I might give you a little bit of background in case you're not really familiar with Inductive Automation or Ignition. Just a 50,000-foot view of what we are, what the architecture looks like, so that the demo will make a bit more sense to you. So if we take a look at the actual platform, the Ignition platform is a SCADA MES IoT platform. And what Ignition does, we have an unlimited licensing model. We're able to run on multiple different platforms, so cross-platform compatibility. We have a lot of IT standard technologies built into the platform, and we're based on those. We're scalable in a server client type of architecture, as well as a publish-subscribe architecture, which we'll talk a little bit more about in just a minute. We're web-based, we're web-managed. The clients are web-launched on desktop and mobile. And then the Ignition platform is modular as well. The modular configurability is an important aspect of Ignition. And we'll talk a little bit more about modules in just a second. And then, of course, Ignition is a rapid development and deployment platform. Now, if we take a look at a simple architecture, Ignition server is going to be sitting in the middle, connected up to PLCs, connected to databases, and then you have clients that are running, designers that are looking at that Ignition server. This Ignition server in this example of an architecture has a direct connection to those PLCs. So like Robert was talking about with the polling architecture, where you saw the graphic of polling information from multiple different locations, this architecture shows a little bit of that. Now, we wanted to expand what our offerings were back in 2017, so we added a product called Ignition Edge. Ignition Edge is intended to run on edge devices. So Moxa's IoT edge gateways that they have are a perfect example of a device that Ignition Edge runs on very well. And in fact, in our demonstration, we're going to see that architectures with Ignition Edge look a little bit more like this. So you'll have different edge devices, different edge gateways that are sitting in different locations, and Ignition will be central, and these different devices and gateways will be pushing information up to Ignition. Ignition could be polling, Ignition could be doing pub/sub, publish, subscribe type of methodology out to these devices as well. And in the upper left there, we are showing a little bit about MQTT, which we'll dig into a little more. Ignition architecture for the individual server there, if you take a look at that central Ignition gateway, the architecture looks a little more like this. So inside that gateway, the Ignition platform is there. It can run on any operating system. And if we're going from the bottom to the top, beyond the operating system and the platform, you have core modules. Each one of these modules is pieces of functionality that plug into the Ignition platform. So you could almost think of it like your cell phone, and you have apps that you install on your cell phone. In Ignition, you have modules that install into the platform. These MQTT modules are a good example of modules that plug into that platform. And so the MQTT modules give Ignition the ability to talk over the MQTT protocol. The MQTT protocol is a protocol that really allows for a pub/sub type of architecture. And this is showing off what that looks like. So basically, these you start with these coupled devices and applications where you have the traditional polling model. You have MES talking to PLC, you have PLCs talking to your analytics system, your SCADA system talking to everything. And every time that you want to put something new on your system, you will add another new connection. And each new connection takes a certain amount of engineering time. If you think about simplifying this diagram, you normally don't think of simplifying something by adding something, but in this case, that's exactly what you do. So rather than have all these connections in the center, you simplify it by putting a broker right in the middle that's going to act as a traffic cop and essentially allow everything to talk to one place, talk through one place, I should say. So you have publishers on the right-hand side, and you have subscribers on the left-hand side. Each one of these publishers sends messages up to this broker, and each one of the subscribers can decide what they want to listen to. One of the really nice things about this architecture is it means that any system that you put on the network, as long as it speaks MQTT Sparkplug, it's going to be able to plug in, it's going to be able to see everything that is available over this message-oriented middleware, everything that is on the system at the same time. So you plug in a SCADA system, you can see the information there. You plug in some other IT systems, plug in an MES, you plug in an analytics system, and it's able to view the entire infrastructure generally in seconds. So millions of tags, it's not really a problem. This scale's really large. Ignition Edge takes advantage of this. So we offer an MQTT module offering with Ignition Edge. We've seen that Ignition Edge is being chosen by OEMs even more for either pre-installation on the devices or for having a set of install instructions that give you a quick start guide for how do I get started, how do I install Ignition, put this on the device, and be up and running in a few minutes. It's really exciting for us to see this, and Moxa is one of the big partners who we're doing this with. So Moxa has several different offerings on the Edge IoT gateway side, in addition to the industrial PC side, that all are really good at running Ignition, both running Ignition Edge and running a more full Ignition gateway if that's something that's needed. Now, no ecosystem can have just one partner, and most companies in integration don't want vendor lock-in, and we're very much aligned with Moxa when we come to supporting open protocols, supporting a wide variety of protocols. The ecosystem does have multiple different folks inside it as well. So Ignition Edge runs on a number of devices, comes in pre-installed on a number of devices. And the MQTT Sparkplug ecosystem has even more partners in it for folks who support the protocols out of the box. Now, in this case, I'm going to be demoing the Ignition platform connected up to an MQTT server. So this is the architecture for what we will be seeing here in just a moment. So on the left-hand side, there's the Edge gateway under the number 1. That is a Moxa Edge gateway. In this case, it happens to be a Moxa UC8100 that is sitting here in our offices that is doing communication. And what we're going to do is through an MQTT server that we have here in our offices, we're going to connect the Ignition platform up to that, which will make the tags that are available inside that Moxa immediately available to Ignition. I'm also going to do a little bit more connectivity, which will be a little bit of a surprise. So I'll show you that in just a minute. So as we're going into this demonstration, I'm going to show my desktop. And my desktop on this system, I've downloaded from the Inductive Automation website, the Ignition installer. The Ignition installer is, there we go. It's now sharing. The Ignition installer is available. Anybody can download it from our website. And I'm going to actually take you through a fresh install. So this is from zero. You can do this yourself on your own computer later if you're interested in doing so. And I mentioned before, we have Ignition and Ignition Edge. I'm going to choose the normal version of Ignition here and go through the install. As I also mentioned, Ignition is cross-platform. So this is the installer for Windows. If you happen to have a Mac OS computer, you can download the installer for Mac OS. If you have a computer that is running Linux, or if you have a server, you can download and install the version for Linux. I've now installed it, and I did that so quickly I clicked past the part where it confirmed the installation, and at this point it's going through and it is starting Ignition behind the scenes. I mentioned modules earlier. I also downloaded this MQTT engine module, which will give us access to MQTT and access to the IIoT type of communication that you can do from Ignition and from a number of other systems. Now, Ignition is starting up on this local computer, and it's going to be accessible over a web page. Wherever it installs and wherever it is set up, you're going to be able to go to that computer's IP address inside your web browser and then connect up and launch up Ignition directly from there. It opened on my other monitor here, so I dragged it over. This is the Ignition Gateway web page right here. And what this is showing is that we're installed. We're sitting there at localhost, and we are up and running. So now that Ignition's here, it gives us a 2-hour trial. I'm going to come in and configure the connection out to my MQTT broker. We have security built into the platform every step along the way. So that is, we've got a default username and password that I just logged in with, but you can of course set that up, and you should set it up to be whatever you want it to be. If we come over here, the first thing I'm going to do is install that MQTT module. So I'll come down, install a module, pick this from the desktop, and install. It's going to take it just a second. There's an agreement. A number of our modules are provided by third-party partners. In this case, this is coming from CirrusLink Solutions. CirrusLink is the CEO, I believe, of CirrusLink is the co-founder, co-inventor of the MQTT protocol itself. So CirrusLink was a really good company for us to partner up with for this. At this point, MQTT is installed. If I come under the MQTT engine settings, can come over, servers, and I will set this up so it connects up to the server that I have inside our office. So this is running at 5.58. And then I'll save the changes right here. It'll submit those, make the connection over to this. And now we can see that we're connected right there. Now that I have this set up, that's really all I need to do. I'll come back under Home, hit the Launch Designer button, and this is going to launch the Ignition Designer. So for now, I'll be done with this web interface. The Ignition Designer will start up right here. Sorry, I had the debug console on earlier. Normally you won't see that. It'll just pop up with the designer. I'll just call this project a demo and create a new project. And inside the Ignition Designer, we're going to have multiple different panels. If you've never seen the Ignition Designer before, quick orientation, the project browser in the upper left gives you access to all the different sections inside Ignition. This tag browser gives you access to tags. Then you have a screen designer out here, a report designer, and quite a few other things. What I'm going to do is just pull up screen designer. I'll pull up one of these main windows and then just drop some information here. I'll come under my tags, and you can see tags doesn't have much inside it right now. But if I drop down under all providers, I've got my MQTT engine. I haven't set up any direct device connections. Only thing that I've connected up to is that MQTT broker. If I expand this out, you can see my edge nodes, and there's Folsom. Inside Folsom, we have the Moxa 8100 that is sitting over here. And under the Moxa 8100, we have a number of different tags that I have accessible. Now keep in mind this was immediate. Folsom popped up here as soon as I connected up because that's how the Moxa 8100 is publishing its information.
So Kevin, this is Robert. I think I must share for our audience that you're located in Folsom, California. This is not that we're monitoring from the Folsom prison.
No, we're not in the prison. So thanks for that comment, Robert. So I'm gonna pull up the rest of the tags here. So these are all streaming back from this 8100, and all of these tags are actually live there. You can see the values changing, and for these different values, if I drag them out to the screen, we can see what they're doing right now. Ambient humidity, ambient temperature, discharge pressure, and the point of this is we have all of this immediately, instantly accessible. I also have the ability, if you have permission, to come in and do some control. So we could come over and take this motor, we could show the amps there, and then we could actually turn this on and off if we wanted to. This is running from a simulator, so it actually has some amps when it's in an off state, but you can ignore that from a moment. So this is an internal simulator inside the Ignition software, but this is live streaming over MQTT over our local network here. And of course, if you wanted to make this look a little better, you could come in, you could make some sort of motor that this was attached to. You can set this up so that it had some sort of coloring that was associated with this. And based on those amps, we're going to have maybe a simple green to yellow to red coloring that shows that we're off and it's gray, or if we're on, then it is up and running, for example. So in any case, this is the whole idea. So you have all of this information available right at your fingertips. You can take this information, you can display it on screens, you can show it off to dashboards, you can have functional type of systems that are using this information. You can pull it back into reports, you can do analytics with it, whatever you need. So as soon as this is available, you can use this information in really real, practical, simple ways. The MQTT protocol also makes it so that these pieces of information that I have streaming back here, each one of these different tags that I have coming back here, this is super lightweight. So this HOA tag, for example, that has a 0 right now, this is not sending anything over the network. This is just quiet. This is only sending things as they change, and it's sending it in a compressed format. This ends up allowing you to do some things that you could never do before, which with a polling type of mechanism, you'd have to be careful about the number of tags that you pull into a system. Generally, with architectures like this, instead of pulling in 10 tags or 100 tags and the same amount of bandwidth, you can normally pull in thousands of tags, sometimes tens of thousands of tags. So you get an order of magnitude better performance, which ends up allowing you to unlock a lot of those tags that maybe you weren't using at the edge of the network before, but now you want to use. To show this off a little bit, I can show a couple of other brokers that we have available. So just like I was showing earlier, we have architectures where you can connect up to MQTT brokers, and they'll have access to all sorts of different tags that are there. In this case, I just connected up to that Moxa 8100, that IoT edge gateway that Moxa sells. But we could connect up to all sorts of different things as well. So I'll create a new MQTT server connection here, and I'll set this up to go to 2 different places. So first of all, I'll do one called Ignition IoT. We have this available on the cloud. This is available on our own servers here at Inductive Automation. So I'll share this out. TCP IoT, inductiveautomation.com, 1883 for the port. This server happens to be one of the open source MQTT servers called Mosquito. I'm going to connect up with the username and password. And now we can see we're connected. I'm also going to connect up to a system from CirrusLink. CirrusLink, as I mentioned, are the authors of the MQTT modules, and they're our partner, and they've done some amazing work with MQTT Sparkplug spec, which is the industrial spec for MQTT. So if I come under here, I'm going to come in, set that up as Chariot, which is their type of server for MQTT. I'll come in and put in a username and password here. If you'll give me just a second to type this. And hit create, and then that'll connect up as well. Now I have all of these different servers connected, these MQTT brokers connected now. What do you think it looks like inside the Ignition Designer? Well, all I do is I run right back over here, I refresh my edge nodes, and I have access to everything. So these are all different demo devices that are available on those MQTT servers. You can see in addition to the Folsom folder that I had before, we have devices that are publishing out from a number of different companies here. And the thing that's the most interesting is this Moxa swarm. So if we take a look at this, these are all different devices that are coming through. And if I expand any one of these out, we're going to be able to see a whole set of nodes that are coming back from each one of these devices. You'll notice that inside this node, we also have values that are actively changing. These are changing more than once a second. So these look like about once every 500 milliseconds. And you're not seeing any delay on this. I don't know if you're seeing any delay over the meeting here, but on the live system, this is instantaneous. This is just coming through as fast as this changes. And keep in mind, this isn't in our offices. This is online. This is coming from, I believe this is coming from Kansas City in this case for some of these. We have other devices that are coming from AWS, from other places that they're hosted out. And if I pull in any of these guys from any of these Moxa devices, a number of them are simulated, some of them are real. If we pull in these guys, I can pull these out, I can show them on the screen. Doesn't really matter, they're instantly accessible. And you can see from the devices here, each one of these has about 100 devices in it. We're looking at 700 devices that are all just instantaneously available, all coming back over MQTT, over Sparkplug. And once again, that is one of the protocols that's built in on the Moxa devices themselves. So in addition to running Ignition Edge on the Moxa devices, you can also speak Sparkplug to the Moxa devices out of the box. That wraps it up for the demo that I had here. Hopefully that was interesting. There's definitely going to be a chance for Q&A at the end, and I know that folks probably have questions on some of the things that I was showing here. But I'm going to circle back and take a look at the architecture diagram that we started with. So as we go back to the slideshow, back to the PowerPoint that we have here, we're going to be taking a look at the architecture that I started with, and I'll orient you a little bit to the different pieces of that architecture that we had set up. So inside this architecture, that central ignition gateway, that's what I just installed. On the upper side there, the remote field devices, we have the edge gateway, which in this case would be our Moxa, that IoT edge gateway that we do have inside our offices, that we have Ignition Edge installed on, and I just showed connecting up to that. And then the rest of the demonstration was around connecting up to larger infrastructures, where you might connect to a system like this that's already in place that has a lot of remote field devices, that you make an instantaneous connection from a central ignition gateway or whatever system you have that talks to these architectures, and then it immediately becomes available on your system. And with that, back over to you, Robert.
Kevin, thank you. What a great demo to show the scalability of the publish and subscribe protocol and applicability for industrial. Really appreciate it, and appreciate how much software can highlight the benefits. So next, we're going to transition to our third and final poll question. And we're very interested to know what SCADA software you're using today. This is important as we talk about the protocols and the architectures to make sure we're working with you to also outline the SCADA solution and the SCADA approach. So please select whether you're working with Ignition from Inductive Automation, Wonderware from Schneider Electric, and also now Aviva, WinCC from Siemens, or FactoryTalk from Rockwell. We know there are many others as well, so we also left an option up here for others. But now, if you're using software for dashboarding or visualization, please don't consider that others. We're looking really for what you're using for your SCADA software collection today. We'll leave the poll open for just a few more minutes to give everyone a chance. I'll go ahead and ask Scott to show us the results of our third and final poll question. Great. Yes, as expected, there's a lot of SCADA solutions out there. I'm encouraged to see the number of our customers and partners using inductive automation and Ignition. So we're very excited. And we're also very familiar with Wonderware. We speak with them regularly and are aware of the market penetration they have, as well as FactoryTalk from Rockwell. So this feedback actually maps to exactly what we'd expect to see in the market. We encourage all of you to take a look at the new publish and subscribe benefits of some of the more modern SCADA architectures, which many vendors will be offering as we move forward. So again, Kevin, I want to thank you for a great demo that shows modern SCADA and really wrap up our webinar today. So as you can see, in summary, Moxa is seeing three typical architectures emerge with customers who are deploying these IIoT solutions. First is the edge to cloud. Then we are seeing integration with modern SCADA systems. And finally, we continue to see, and will expect to see for some time, a need for edge to traditional SCADA systems and the gateways that enable that. It is important to note that these three architectures I've shown can be much more complex in real-world applications. In reality, many customers might use 2 or even 3 of these architectures in their deployments or across their company, or they have various combinations of cloud and SCADA solutions. And today, Moxa is enabled to help you make sure you can provide that interoperability and connectivity no matter which one you've selected. Regardless of the complexity, as this technology continues to enable productivity gains, Moxa offers connectivity for both existing industrial networks and the forward-looking industrial IoT networks of the future. The edge connectivity spans from Ethernet switches and industrial protocol gateways to edge gateways that enable the device connectivity platform that ARC outlined. We now have a few minutes for questions, and with that, I'd like to introduce once again Scott to lead us in the Q&A section.
Thanks, Robert, and thanks to everyone who submitted some really great questions throughout the presentation. Looks like we have approximately 10, maybe 15 minutes to address some of these questions, so why don't we get started, and I'll start rattling some of these off. So the first question is for you, Kevin. What are typical applications for publish subscribe architecture?
Good question. So we have what we've seen is a lot of applications that are in wide geographic distributions. So that often means industries that have different stations that are in different locations. So water, wastewater is a really good example. You have a really low powered, low cost industrial gateway that does its job, does one job, does it really well, sits out at a wellhead, let's say, or pump station, and it's going to be sending information back to a central location. A number of the Moxa devices have cellular built in, and so really good application for putting something out there and then just sending information back centrally. So the geographic distribution makes a lot of sense, especially if you're doing things with cell signals that are really kind to low bandwidth. So that's one application. We've seen a lot inside oil and gas, where you have distributed well pumps, pump off controllers, things like that, that you might want to send back to central location. And then we've also seen a number of manufacturing companies and other companies that have a lot of facilities that want to centralize their data collection over all of these facilities, who are either implementing this or exploring it at this point to take information back from all of these multiple facilities, make it accessible from some sort of corporate view so that you can do reporting, you can run analytics, and you can have that information available in real time, not just summary information, but real time at your fingertips.
Great, thanks, Kevin, for that answer. So the next question for Robert, does Moxa offer IIoT gateways with multi-core processors?
Yeah, great question. And in fact, we do. There's a wide range of options. We've got both quad-core i7 options as well as dual-core Atom available. Of course, we can support either Linux or Windows OS. And so really this intelligent edge gateway option from Moxa is a wide-ranging platform with device management software, as ARC has mentioned.
Perfect. And you mentioned Linux. So one more question for you, Robert. What version of Linux does Moxa support for 10 years?
Sure. So we're based on Debian Linux, which is very common in the industrial space. But I'd also like to add that the ability for us to make sure that you have 10 years of long-term support on top of that Linux OS is really one of the differentiating features. Okay,
great. Thanks, Robert. Kevin, the next one is for you. How large can IIoT architectures scale to?
You know, I mentioned really quickly in passing during the demo the idea of size of one of these systems, but it's pretty typical that you'll see something that starts small and gets really big, or it could even start big. We have customers who are looking at systems that have millions of tags inside them. So you can normally go pretty much as large as you want. Of course, there's redundancies that are available. There's the ability to have multiple MQTT brokers if you need more than one. And in fact, inside the demo, you saw me connect up to 3 different MQTT brokers that ended up expanding the number of tags that were coming through. So in reality, there's no upper limit to this architecture, none that any of our customers have ever found before. And it's exciting to really be able to see people put just about everything on one of these architectures.
Thanks, Kevin. This is Robert. I know we spoke during this about how large you could scale in real world applications, and you brought up a really good point that a lot of these applications at scale are under NDA. So I just want our audience to know that there really are applications at scale for these new modern SCADA architectures that they tend to just be very important and NDA type material for the end customer.
Great, thank you both. The next question is for you, Robert. Is ThingsPro required to manage Moxa hardware?
No, ThingsPro of course has great benefits, and it's a really useful tool for for local web APIs. But we also offer a remote web API for customers who want to integrate into other device management solutions or even build their own.
Fantastic. So quick time check. Looks like we have room for about 5 more minutes worth of questions. So we'll continue on with a couple more and see how far we get through. All right, so the next question looks like it's for you, Kevin. Why would anyone not use MQTT?
That's an interesting question. There are a couple of reasons. So sometimes if you have polling set up, you have an existing architecture. Let's say you're not in a greenfield, you're in a brownfield situation. So you already have things that have been installed. You already have some OPC servers in place that are set up. If it's working and you don't need to get access to that data from outside, or you don't need to switch your architecture, that could be one reason. So you have things that are already in place. Sometimes I've also seen it where people have really small systems. So let's say you've got an Ignition Edge installation that's sitting on one of these Moxa IoT gateways that all it's really doing is communicating back and forth to a PLC. Even though the Moxa devices have support for cellular, maybe you're not using that. Maybe there's no connectivity to the outside world, and all you have is just a really small architecture there. Instead of installing a separate MQTT broker inside that small architecture, if you know that it's going to be an isolated system, there's really no need to have MQTT inside there at all. You can do direct communication back and forth.
Great answer, thanks. Okay, we'll wrap up with a couple more. Robert, I think this one's for you, but Kevin, chime in if it's related. So the question is, will the IIoT gateway be displaced once the publish-subscribe protocols become more pervasive in the controls layer?
Well, that's a great question, and I think it really hits at the transitions we see in the industrial space. It's a really good point that at some point we might see many of the protocols and many of the existing installed field devices using publish subscribe because of its benefits. But I think everyone is familiar with how long we saw serial and some of the traditional protocols still to this day in use. And so really these gateways are a way to take your existing brownfield applications, modernize them so you can connect to the cloud without doing a full rip and replace. But if you were to choose to do rip and replace, by no means is Moxa against that approach. We've got an entire line of networking equipment that's well suited for the new modern publish subscribe APIs. But I think we'll continue to see for at least a decade, and I'm not too strong a predictor, but it could be longer, both the coexistence of polling and publish and subscribe, and these gateways will play a critical role.
And I would add just a little bit to that. The one thing I haven't seen any moves towards, and I'm not sure that there will be moves towards even in the next 10 or 20 years, is taking a device like a PLC and putting cellular directly on it. One of the advantages of these IoT gateways is that they have the connection back to cellular or satellite built in. And that's something that I think these systems are going to continue needing pretty much forever. So maybe at some point, some of the device manufacturers will start embedding those inside PLCs or PACs or whatever the acronym is that they're calling these now. These devices, but I think there's always going to be a role for having a gateway that does the communication out from any type of remote station. And if it's just a pass through for pub/sub protocols in the future for certain protocols, as opposed to doing that protocol and doing polling on the other side, it's still going to be a useful piece of equipment inside your cabinet.
Great point, Kevin. And I'll just reiterate for the audience, we're ready today to deploy these edge gateways and help make sure you don't have to replace your entire installation to gain some of the benefits of cloud infrastructure.
Great, guys. Looks like we have time for one more question. So the last one, it's what options do we have for our installed base of PLCs and controllers to be MQTT capable?
I think the short answer are these intelligent edge gateways. They're really that conversion opportunity for you to install and easily upgrade your system to connect to the cloud. And they're not just a Moxa trend. This is something the ARC and the other industry analysts are defining as one of the core enabling elements of the industrial IoT.
Great, thank you, Robert. So unfortunately, that's all the time we have for questions. So we're going to wrap things up. So if we missed your question, or if you want guidance on a specific situation or issue, feel free to reach out to us directly at usa@moxa.com. One last thing, you'll see a survey after the broadcast. If you could please spare just a few more minutes to complete this survey, as we're always looking for ways to improve our future webinars. With that said, I want to give a big thanks to everyone for joining us today. Until next time, have a great one.